Today we're going to start our unit on radical functions. So a radical is a special name for anything with a root. It could be a square root, a cube root, a fourth root, any kind of root. Those are called radicals. So this is the square root function. Now notice it looks like kind of like you turned half a parabola on its side, because that's kind of what we did. So here it is. Now some points that we might use if we were putting this into our calculator or if we were drawing the graph, we would start with 0, 0. Because I can't take the square root of a negative number, so there's no numbers to the left. 0, 0. Another point would be 1, 1, because the square root of 1 is 1. The next point I would pick would be 4, 2. 1, 2, 3, 4, 2. And then the last one that'll fit on this graph is 9, 3, which would be right here. And when I connect them, it makes kind of a curve like a sideways parabola, just a portion of the sideways parabola. Now my domain is from left to right. I start at 0. 0 is included, so that uses a bracket. And then the arrow means I continue on to infinity. And infinity always gets parentheses. So if I move my graph to the left or to the right, this domain is going to change. My range from bottom to top, I start at 0. So again, a bracket around 0. And this arrow, it doesn't look like it, but it's going to get bigger and bigger and bigger, and there's no end to how big it can get. So it goes to infinity. So if I move my graph up or down, or if I reflect it over the x-axis, this range is going to change a bit. All right, just a reminder about our transformations. Remember, negative a is a reflection over the x-axis. If the absolute value of a is greater than 1, it's a vertical stretch. If the absolute value of a is less than 1, it's a vertical compression. And this k value is also a vertical. That moves it up or down. Plus k moves it up, minus k moves it down. Now we're going to introduce you to something a little bit different this time. You've never had a b value before. Now this b does the same thing that a did, only to the horizontal. Now you're not going to have a negative b, but if you did, it would be a reflection over the y-axis. And I don't think we're going to ask you for that. But what you do want to know is if the absolute value of b is greater than 1, it's a horizontal compression by the reciprocal. So for example, if b was 2, it'd be a compression by a half. So everything under here is opposite. Remember how the h moves opposite of what you thought it did? Well, that's what b does. If the absolute value of b is less than 1, that's a horizontal stretch by the reciprocal. So for example, let me give you one. If you had f of x equals the absolute value of 2x, that would be a horizontal compression by 1/2. If you had f of x equals the square root of 1/3 x, that one would be a horizontal stretch by 3. So it's always opposite. H, you already know a negative h moves to the right, a plus h moves to the left. Always opposite. All right, so this one we're just going to talk transformations, domain, and range. So here goes. So my transformations here, that 3 is a vertical stretch by 3, and x minus 10 to the right, 10. So if you pictured this graph, we're going to stretch it by 3 and move it to the right 10. I can just kind of think about it like that. So my domain starts at 10 because I moved it to the right to infinity. And my range, notice I didn't move up or down. So my range did not change. It's 0 to infinity. And that starting one is a bracket because it's included. Now let's look at number 2. This negative in front is a reflection over the x-axis. X plus 2 means I went to the left 2, and then I went down 4. So just picture your graph. Left 2, down 4. Now if I reflect it over my normal graph, my parent function looked like this. So imagine I reflect it over the x-axis. Now it looks like this. It's the other side of if you picture the top of the parabola, the bottom of the parabola. So this domain, we moved to the left 2, so it started at -2 to infinity. And my range, you have to be careful. If I go bottom to top, I start at -infinity up until this -4. So just note, if it's a ROXA, you go from -infinity to the y value. The domain still stayed the same, but if it's a reflection, take note of that. Number 3, we've got several things going on. We've got a -a, so that's a ROXA, reflection over the x-axis. That 2 is a vertical stretch by 2. This 3, now remember this is all opposite land. So it's horizontal, but it's a compression by 1/3 because it's opposite of what you think it is. And then we'll continue. The +4 moves to the left 4 and then down 7. So the only thing new is this b value that does weird things. So if I'm just going to sketch a graph so I can get an idea. It reflected. I went left 4, down 7, and because it's a reflection, it's the bottom side. So my domain goes from -4 to infinity, and my range, because it was a reflection, starts at -infinity and goes up to -7. And -7 gets a bracket. All right, let's keep going. This one, I've got 3/2. Is that bigger than 1? I think so. So that's a vertical stretch by 3/2. X minus 1 goes to the right 1, and then that +5 goes up 5. So if you're picturing your graph, right 1, up 5, it was not a reflection, so it's the top. So my domain starts at 1 to infinity, and my range goes from 5 to infinity. So the only time the range switches is if it's a reflection. Number 5. I've got my reflection over the x-axis. Now this 1/2, that's a b value. So it's a horizontal. Now it's opposite of what you think. It's going to be a stretch by 2. Remember, opposite, the horizontal. X minus 3 goes to the right 3, and then +2 goes up 2. So if I'm sketching a graph, I went to the right 3, up 2, and I reflected. So it's the bottom. Domain goes from 3 to infinity. Range, because it reflected, goes from -infinity up to 2. All right. On the next page, we have a couple of thinking questions for you. So over here, let's take a look. Number 6 says, given y equals square root of x, write the equation with this domain and this range. So remember, if the range flipped to -infinity, then it was a reflection, but this one's not a reflection. So what this tells me for the domain is that it went right 3, and for my range, it went down 3. So let's see what that looks like in my graph. Square root of. If I go to the right 3, that should be x minus 3. And then down 3 would be a minus 3, but on the back, outside of the square root. Sometimes I put a little line down just to denote that the square root has ended. Now the next one, same thing. This negative 2 to infinity tells me that I went to the left 2. And take a look at this one. It goes from negative infinity to 5. So I know that it's a reflection and it went up 5. So that's going to affect how I write my equation. Y equals Roxa negative square root of, if I go to the left 2, that's x plus 2. And then I went up 5. So this notation here tells me it's a reflection, and that's why there's a negative in front. Let's take a look at this one. This point right here looks like it's negative 3, negative 2. So I know I went to the left 3, down 2, and it's the bottom side, so it was a reflection. So let's denote all of that in our equation. And remember, when you write an equation, you have to put y equals, or it's not an equation. Either y equals or f of x equals, one of those notations. Reflection, left 3, down 2. And there's our equation. So that's a little talk about transformations. And now you practice.